Okay, hello guys. And this is a late discussion na, no? Pasensya na ngayong Sabado ko lang siya ma-upload. Okay, ang dami nangyari last time eh. But anyway, so before we start, no, let me remind you na yung ating material ay andito sa Module 2, Chapter 2. Kapag is-clinic mo yan, ito, pag clinic nyo yan, lalabas itong page na to. So ito yung ating lesson, ito yung ating thermodynamic data. So please download them. Nasa last page na tayo nito eh. Okay. Yung discussion video, I will upload this after this session. Okay. And I will notify you kapag available na siya. Also, after that, pag clinic nyo yung next, no? Pag clinic nyo yung next, ayan, mapupunta kayo sa prob set. Okay, so you're going to answer the prob set again by group, no? Para mas less yung ating hirap, no? Para distributed yung questions. And I added problems here other than those na gagawin nating prob set questions then, no? So ito pandagdag to. Okay. So just click on that. And then, ayan. So I added 5 questions here. Yung 2 and 3, medyo mahirap siya, no? But madali lang yan once na makita mo na yung hinahanap. Okay. So, sa number 2, basically, yung engine mo, gagamitin mo to lift an object in the form of work. Okay. So, pwede mo isolve yung work dyan. Dito naman, sa number 3, okay. So, sa number 3, kailangan mo daw gumamit ng refrigerator to lower down the temperature of an object and gaano katagal, no? So remember that power is the work over time. Okay, so you can use the work pa rin. Okay, so you can use the work dito sa item 3. Okay, so I will leave that to you to work on, no? Although nasa Google to, pero mas maganda kung alam nyo kung paano iikot yung problem. Okay? Kasi pagdating nyo sa physics, madadaanan nyo uli yung ganitong problem eh. Okay? So, kaya ngayon pa lang medyo introduce ko na kayo sa ganyan. No? Kasi babalikan nyo yan sa physics. Okay? So, ito, number 4, number 5, this is something to do with our discussion today. Okay? So, before we start na, ayun lang. So, wait until mabasa nyo yung post later na available na yung video. Okay? So with that in mind, maybe we can start our discussion now. Okay? So it's already midnight here. Okay? So ngayon lang ako nagka-time. No? Okay. So let me begin with the last topic for chapter 2, which is on Gibbs free energy. Ano yung problem na iniwan natin last time? Ang in-emphasize ko sa inyo is yung entropy that can help us determine kung ano yung direction ng reaction, no? It is always forward, no? Kaya nga sabi nila, the arrow of time is the entropy, no? So yun yung sabi nila sa mga sci-fi, which is somehow totoo naman, okay? Kasi sabi natin, we tend to go into disordered state parate, no? Meaning that the entropy of the universe must be positive. Okay. So, for chemical reactions, for example, itong ginawa natin dito, for chemical reactions like this, no, papansin nyo that in order for you to determine if the reaction is spontaneous or not is you have to solve for 2 entropy values, no? Dalawa yung isosolve mo. The delta S system and the delta S surrounding. Ipag-add mo yun, then kung pag-positive yun, spontaneous yung reaction, meaning that will proceed forward, no? Yun yung problem sa entropy, no? Although it allowed us, no, to get a better understanding of the universe, no, medyo mahirap pa rin siya gawin in reality, no? Kasi nga, dalawang beses ka magsosolve eh, no? So, medyo effort yon. Okay. And as much as possible, scientists want to make things simplified, no? Kaya they developed another energy form, okay, which is the Gibbs free energy. Okay, so again, take note, bakit kailangan natin tong energy na to? Kasi sabi nga natin, delta S universe ang basis ng spontaneity dati. Kaso, in solving for delta S universe, you have to solve for delta S system and delta S surroundings. Dalawa isosolve mo, no? And technically, mahirap talaga isolve yung delta S surroundings, no? Kasi hindi lang naman yung heat from the reaction to the surroundings yung magko-contribute, no? May other factors pa, no? So, we are doing approximations lang doon, no? Kaya, that's why we have to do this, no? This is the last topic naman na, so please bear with me, okay? So, yun yung motivation natin why we have to discuss this, okay? And also, sabi ko rin dito, we are more concerned with the particular system rather than the surroundings. Okay? So, ang gusto kasi natin, lahat in terms of system. Bakit? Kasi yung system yung focus mo sa thermodynamics, di ba? Pag sinabing system, doon ka lang nakatingin. As much as possible, ayaw mo pansinin yung surroundings. Okay? So, yan, we need to do something in order to get another energy term that will focus only on the system. Okay, so recall that for spontaneous process, we have this equation, delta S universe equals the sum of delta S system, delta S surroundings. Pag pinag-add mo yan, tas positive yan or greater than 0, that means spontaneous yan. Okay? And also remember that the delta S surroundings is given as the negative delta H system over T. Dinerive natin yung last time, di ba? Okay. So, substitute mo yan dyan. Okay. So, you now have this equation. Then, you cross-multiply the T. Okay. Multiply mo all sides by T. So, you have T delta S universe, T delta S system minus delta H. Okay? So, yan. Multiply mo negative lahat. So, you have negative T delta S equal delta H system minus T delta S. If that is less than 0. Bakit siya naging less than 0? Kasi, pag minultiply mo yung inequality by negative sign, babaliktad yan. Diba dito greater than 0? But since minultiply natin siya by negative 1, yung inequality magre-reverse. Okay? So from greater than 0, magiging less than 0 siya. Okay? So ano implication na to? Itong last line na to. What's the implication of this equation? Okay. The implication of this equation is that for you to determine the spontaneity of reactions, all you have to do now is to just look for delta H and the delta S of the system. Okay? Kasi ito yung ito yung magsasabi ng spontaneity, no? Okay? At andito yung delta S universe, no? So, andito yung delta S universe and this will predict kung yan ay spontaneous or not. Okay? So, in order to determine if a process is spontaneous or not, kailangan mo na lang daw pala gawin is yung delta H, pati yung delta S system, pati yung temperature, yun na lang alamin mo. Which is better. Bakit? Kasi, system to. Ito, system yan. Ibig sabihin, we don't have to take into account the surroundings. Okay? Hindi mo na kailangan i-solve pa yung nasa surroundings, yung delta S surroundings. No? All you have to know is this one and this one, which is madali gawin. Okay? And if they are less than 0, then we can say that this quantity is spontaneous. Okay? So, yun na yung bagong criteria natin. Hindi na siya greater than 0. Naging less than na. Kasi nga, we multiplied negative 1 sa entire equation. Kaya bumaliktad yung inequality symbol. Okay? So, in order to determine spontaneity, the difference of these two quantities should be less than 0. Okay? But what is this, no? What is this negative T delta S universe? Ano tawag dyan? Okay. Ngayon, punta tayo ngayon. Okay. Papangalanan natin tong negative T delta S surroundings kasi kailangan may tawag sa kanya. Okay. But yung iba, okay na yun as is. Okay. So, in order to have a name for this term here in the equation we just derived, okay, we introduce another energy form which is called the Gibbs free energy. Okay. So this Gibbs free energy is another energy form, which is the difference of the enthalpy and the product of temperature and the entropy. Okay. So pag susubtract mo lang yung enthalpy and yung product ng temperature and entropy. Okay. So if you get the derivative of this at constant temperature, so for example, you have an isothermal process, kunin mo yung derivative niyan, so you will get your dg, dh, derivative of ts will be ano? Ano may yung derivative niyan? That's t ds plus s dt. Okay? However, constant nga yung temperature, so mawawala tong term. So, we will only have T delta S. Okay? So, yan. So, this is now the Gibbs free energy. Okay? Delta G equals delta H minus T delta S ng ano? Ng system. Okay? So, this is delta H of a system. This is delta S system. And so, that means this delta G is for the system then. Okay? And yun yung magiging pangalan ng itong term na to. Yan yung magiging new name niya. So instead of calling it negative T delta S universe, we will just call it delta G. Okay? So yeah. So instead of using entropy of the universe, we will now use the free energy change of the system. Okay? And to solve for the free energy of the system, the equation is simply delta H minus T delta S. Okay? Okay, now take note that if our delta G is negative, then that means it is spontaneous. Okay? And we don't have to worry about the universe anymore. No? Hindi mo na kailangan magtingin sa surroundings. No? Kasi yung system na lang yung focus mo. Enthalpy niya and the entropy. Yun lang. No more. No more surroundings. Okay? So yan. Take note na negative dapat yung value nito for it to be spontaneous. Let me ask you again, saan galing yung negative sign? Noong minultiply natin itong equation na to by negative sign, nag-flip yung inequality. Okay. So that means this quantity should be less than 0, meaning negative dapat yung value ng delta G para maging spontaneous yung process. Okay? So meaning if we have delta G less than 0, the reaction is spontaneous. If we have delta G greater than 0, the reaction is non-spontaneous. And if we have delta G equal to 0, that means we have an equilibrium system. Okay, when we say equilibrium system, balance yung system. Okay, so there's a balance in the system. Okay, so luckily for us, no, in order for us to solve for delta G, madali na lang. Okay, okay. So just like what we did sa entropy, enthalpy, no, there's another way of solving for delta G, which is this one. Suppose you have this equation, delta G of the reaction is the moles times the GF product minus moles times the GF reactant. Okay? So, ganun pa rin naman. Same lang ng ginawa natin sa entropy. Okay? So, given na naman yung delta GF nila, yung free energy change na standard, no? So, all you have to do is just look up the table, multiply mo yung coefficients, then you add them up, you will get your delta G reaction. If that is negative, then that is spontaneous, otherwise that's non-spontaneous. Okay? So let's try to do some problems here. Suppose we are asked to solve for the delta G of this equation. We have CH4 plus 2 oxygen gas producing CO2 and 2 water in the liquid form. Okay. So as I told you last time, we can use the thermodynamic table we used last time. Okay. So we can use that dito. Let me transfer it here. Ang kailangan natin ay methane, CH4, asa yan CH4? Wait lang CH4. Nasa dulo ata. Wait lang. Hanapin natin yung delta G values nila. Ito. Sa dulo yung mga organic. So, for methane, ayun, methane. So, CH4, asan yung ano? Nasa gitna. Remember, nasa dulo yung entropy. Nasa gitna yung delta G. So, for methane, the delta GF in the gas phase, negative 50.2. Ano unit? Let me check. Kilojoule per mole daw. Okay. So, oxygen, kailangan din natin. Nasa problem yun eh. Oxygen. So, oxygen gas, 0 daw. Okay. And then we have carbon dioxide, delta GFCO2. Hanapin ang carbon dioxide. So this one, negative 394.4 kilojoule per mole. And then we have the water. Take note that the water should be in liquid form. Okay, baka kasi makuha nyo is yung nasa gas form. So water in the liquid form, H2O. Magpas ako. Okay, so yan. So given all those, no, let me show you yung sinulat ko. So kinampihan ko lang yung mga delta G values natin. Okay, so ganun lang din gagawin nyo kasi given na naman yun. Okay, so just look up for their delta G values sa ating table. Then yan, just use the formula we used last time, no? Products times their coefficient minus reactants times their coefficients. Okay, so that will give you the delta G reaction. Okay, the delta G reaction is the products. Okay, so yung CO2, we have 1 mole of carbon dioxide times this delta GF plus 2 moles ng water, liquid water, that is negative 237.2 kJ per mole, minus, sa reactant tayo, we have 1 mole of CH4, negative 50.8 kilojoule per mole. And for oxygen gas, wala na tayong gagawin kasi 0 yan. Okay? So, di ko na siya isusulat. Okay? So, with that, solve natin yung delta G reaction. Okay? So, solving for delta G reaction will give us, let me calculate it. Negative 394.4, 2 times negative 237.2, 1 times negative 50.8. Okay, so the delta G is negative 818 kilojoule. Take note na yung mga moles ay nag-cancel out. Mga moles nag-cancel out na sila. Okay, so given that delta G reaction is negative in value, that means this is already spontaneous. Diba, dali na? Bakit? Kasi kung ito ay entropy, hindi mo pa masasabi. Okay? Hindi mo pa masasabi kung ano yan, spontaneous o hindi. Kasi kailangan mo ng delta S universe, no? Kapag entropy usapan. But kapag delta G ang usapan, basta negative value niyan, spontaneous yan. Okay? So, yun yung gusto ng scientist natin. Yung mas madali yung buhay. Okay? So, you don't have to solve for the delta S surroundings anymore. Kasi, with delta G, with the free energy change, kailangan mo na lang hanapin yung value ng delta G ng system. You can look it up on the table. Kaya you can use the equation delta G equals delta H minus T delta S. Okay? So, yeah. So, I want you to answer the rest of the items for standard free energy change. Alam nyo na naman kung ano gagawin dyan. So, products minus reactants lang yan. And then, we will look for the delta GF values in the table we used last time. Okay? Sa ating thermodynamic table. Okay, same process lang. Okay? So, ayan. Let's go back to delta G equals delta H minus T delta S. Okay? So, there are several factors that could result to spontaneity of a reaction. Okay, so suppose you have a positive delta H and a positive delta S. Okay, so suppose you have a positive delta H and positive delta S. Okay, so if this is positive and this is positive, kailan magiging spontaneous yung reaction? Take note that the goal should be, it should be less than 0. Okay, it should be less than 0 for spontaneous reaction to happen. Kung positive ito, at ito positive to, kailan magiging spontaneous yung reaction? Only at high temperatures. Okay, so at high temperatures, if you have delta H na positive and delta S na positive, kailangan mataas yung temperature para maging negative yung entire value. Bakit? Kasi ganito. Take note na itong delta S nakamultiply sa negative sign. Okay? So, ibig sabihin, this whole term is negative, no? So, kailangan ma-overpower niya yung delta H. It should be able to overpower this para mas maging dominant to. And if ito mas dominant, ibig sabihin, the difference is negative. And once the difference is negative, then delta G is equal to 0. So again, take note that if you have positive delta H and positive delta S value, the temperature should be very high. Okay? So the temperature should be very high in order for the reaction to be spontaneous. Kasi kung mababa yung temperature mo, mas magiging overpowering itong delta H. Pag mas positive to, edi non-spontaneous yan. Okay? So if you have this case, positive yan, positive yon. So this one should overpower over this. Bakit? Kasi nga, kailangan negative yung value mo para maging spontaneous yan. Okay? Another thing is that, what if you have a positive delta H and a negative delta S? Okay? Take note na may negative sign doon. Kung negative yung delta S mo, minultiply mo sa negative sign yon, this will be what? This will be positive. Okay? So, itaas mo man yung temperature or ibaba mo yan, magiging positive to lahat. No? Kasi negative times negative will be positive. So, kung positive to, positive yon, ibig sabihin, the reaction is not spontaneous. Okay? Because delta G is always positive. Okay? So, hindi magiging spontaneous yung reaction kapag positive yung delta G. Okay? Sabi lang dito, the reaction is spontaneous in the reverse direction. Pag binaliktad mo daw yung process, dun lang siya magiging spontaneous. Okay? Let me talk about that later. Okay? So, yun lang. If you have a positive delta H and negative delta S, always delta G is positive. Okay? Kasi nga, negative times negative is positive. So, we have two positive terms here. Another thing, if you have a negative delta H, you have a positive delta S, what will happen? So, ito yung kabaliktaran ng kanina. Always negative to. Bakit? Kasi delta S, positive times negative, negative yan. So, you have a negative term here, another negative term there. Ibig sabihin nun, delta G is always negative. Meaning, it is always spontaneous. Okay? So, the reaction is always spontaneous if you have a negative delta H and a positive delta S. Always spontaneous. Then last one, I you have a negative delta H and you have a negative delta S. Okay, so this is the counterpart of the first statement we discussed. No? Kung negative ito, negative yon, ano mangyayari dito? Negative times negative will become positive. So if you want the spontaneous reaction to happen as much as possible, you must lower down this term. Okay? Kailangan onti lang yung effect niya. Kasi positive to eh. Kailangan mas manaig ito. Kasi gusto mo negative yung delta G mo. Okay, so if you want this to overpower this, then the temperature should be very low. Okay, so the reaction will proceed only at low temperatures. Okay, otherwise, this will overpower this term, making it positive, making the delta G positive. Okay, so ganun lang. Okay, we won't add anything more about this na kasi supplemental na lang naman to. Marunong na kayo mag-delta H, marunong na kayo mag-delta S. So basically, pag-add mo na lang sila. Okay? Okay. So ngayon naman, ito yung medyo important, no? Let's talk about the free energy and the equilibrium, the chemical equilibrium. Okay? So, there's a relationship between standard and non-standard state, katulad lang nan sa enthalpy. Okay. So, for free energy, may relationship ang standard and non-standard state na, and that's given as delta G equals delta G naught plus RT ln Q. Okay? So, when we have a naught, ibig sabihin ito yung standard. Okay? And if we don't have any naught symbol, that means yun yung non-standard. Okay? So, R is the gas constant in energy units, so that's 8314 joule per mole Kelvin. Temperature is in Kelvin, and we have this new term, the natural log of Q. Ano yung Q or K? So Q is actually the reaction quotient. Okay. So what is a reaction quotient? Alam ko hindi ito na-discuss sa Gen Chem nyo, no? Kasi kung STEM kayo, siguro na-discuss to. Pero kung hindi, edi this might be a new idea for you. Okay. So, what is Q or what is K? No. So, Q or K ay equilibrium constants. Okay? Ano ba yung equilibrium na yan na sinasabi ko? Pag sinabi kong equilibrium, ganito itsura niyan. Okay? Mapapansin nyo kasi, typically sa chemical reaction, di ba nilalagay nyo forward arrow lang. Pero may mga equation kayo makikita na may backward arrow lang. May backward arrow din. Okay? So other than the forward arrow, you have a backward arrow. Ano meaning nun? Pag may nakita kayong ganun, equilibrium ibig sabihin yan. When you say equilibrium, that is a state of a system wherein the reaction happens in two directions. One is in the forward direction, the other is in the reverse direction. Okay. So dalawang reaction yung nangyari. One is going forward, the other is going backward. Okay. So actually in human body, there's lots of chemical equations that are in chemical equilibrium. Kasi kung walang ganon, hindi tayo masusustain as humans. Para tayong robot kung ganon. Okay? So, yan yung mga equilibrium reaction, yung may mga arrow na dalawa. Okay? So, ano yung K and yung Q? Okay? So, yung Q is the reaction quotient. And yung K, ito yung reaction. I mean, yung equilibrium constant. Okay. Naglalaro yung pusa ko. Esensya na. Equilibrium constant. Okay. So, ano yung dalawang yan? Okay. So, actually, may numerical value yan, no? But let us solve first kung paano yan sinusulat. Okay. There's a mathematical expression for the two kasi. Okay. So, paano? Medyo similar lang. Okay. So, yung Q and K are similar. So, similar sila ng itsura. Paano ko isusulat yan? Okay. So, umpisa tayo sa K, reaction quotient. equilibrium constant. Kapag sinabing equilibrium constant, that's the ratio of the products over the reactants. No? Ano meaning ko dun? Yung concentration ng products, which is concentration of C, concentration of D, raised to their coefficients, yung small letters, divided by yung reactants. No? So, A, and B. Yan yung, pag sinabi kong, ratio of products over reactants, yan yung ibig sabihin ko. So, you have the concentration of your product raised to their coefficients divided by the concentration of your reactants raised to their corresponding coefficients as well. Okay? So, i-divide mo yung dalawang yan. Okay? Product divided by reactant. By the way, if you have more than one species here, no, kunwari dalawa yan, you multiply them. Okay. So that's how you write K. How about Q? Ganun din. Okay. So ganun din. So CC, D raised to D, and you have A raised to A, and then you have B raised to B. Okay, but however, this should be initial. Okay. So take note that we are at initial stage. No? Ibig sabihin, before the reaction happens. Yan yung value niya. Okay? Practice tayo. Practice tayo magsulat ng ganyan. So let me give you some practice. Okay? So suppose we have this equation here. We have nitrogen gas reacting with 3 moles of hydrogen gas, and that is in equilibrium with 2 moles of ammonia. Write the K and the Q. Okay? Write the K and Q. So again, sabi ko sa inyo, product over reactant yan. So what is the chemical species on the product? So that is NH3. And the coefficient is 2. So gagawin mo yung square. Okay. Ayun. So yun lang yung nasa numerator mo kasi isa lang yung product eh. How about the reactant? Yung nasa baba. So we have nitrogen gas. Ang coefficient niya ay 1. So no need to write exponent 1. Okay. And then you have hydrogen gas. And it has a coefficient of 3. So gawin mong cube yan. Okay. So these two are multiplied. Ha? Take note of that. These two are multiplied. Okay. So that's how you write the K. How about the Q? So for Q, ganun din. Just copy everything. Just copy everything. But you have to write letter I, initial. Okay. So kailangan may letter I, initial. Okay. Before the reaction takes place. Okay. So now you know how to write the K and Q. Balik ulit tayo sa delta G. Okay. So balik ulit tayo sa delta G. So if yan ay standard state, no, the delta G is related to K. Okay? K ang related siya. Okay, so that's negative RT ln K. So that is the equation for the relationship of standard entropy, standard and free energy change with the equilibrium constant. And then if you have a non-standard one, ito yung equation na gagamitin. Hindi siya related kay K. Siya ay related kay Q. Okay. I think it should be positive, no? Ayan. So sorry for that. It should be positive. Okay. So ito yung dalawang equation. So kapag hinahanap yung equilibrium constant, ang kailangan mo ay delta G naught. Okay. Pero kapag ang hinahanap ay Q, ang kailangan mo ay yung delta G. Okay. So they are not the same, no? So kapag equilibrium constant, G naught yung kailangan mo. Otherwise, you need K. Okay. Or you need Q. So let's try to answer some of the problem here. Okay. So, kunwari, dito sa number 1, calculate the equilibrium constant for the following reaction at 25 degrees Celsius and determine the spontaneity. Okay. So, since we are solving for K, hinahanap yung K natin dyan, ibig sabihin ng kailangan natin ay delta G naught. Okay? So, ano yung delta G naught na ito? Yun yung, yun yung equation na ginamit natin kanina. Okay? So, you can use this equation to solve for the delta G naught of this equation. Okay? So, let's do that. No? So, let's find for the delta GF of water, delta GF of H2, and delta GF of oxygen. So, this will give us the delta G reaction, the standard free energy change of the reaction. So, for water, liquid water, this is the delta G value, negative 2, 37.2 kilojoule per mole. Kailangan liquid. Hydrogen gas, H2 gas, ito, so 0. And then oxygen gas is also 0, I think. No? Yes, 0 din siya. Okay? So, yan. So, with those values in mind, we can solve for the standard free energy change. That is product over product minus reactants. No? So, 2 moles times 0 for hydrogen gas. 1 mole times 0 for oxygen gas minus 2 moles times negative 237.2 kilojoule per mole. So, take note, magka-cancel yan. This is 0, this is 0. Ayan, parehas yan may moles. They will both be cancelled. That will give us delta G Rxn equals 474.4 kilojoules positive. Okay, so ano implication yan? Ibig sabihin, this reaction is non-spontaneous. Okay, so that reaction is non-spontaneous. And totoo naman, di ba? Kasi wala naman tayo nakita ng water na biglang nagiging hydrogen gas and oxygen gas. Ang pwede pa is yung water maging vapor. Pero yung water maging hydrogen gas and oxygen gas, walang ganon. Okay. Hindi nangyayari agad-agad yun. No? You have to do something pa for that to happen. Meaning this reaction is non-spontaneous. Okay? So since we have a delta G which is positive, that is non-spontaneous, and meron na tayong delta G naught, hanapin na natin yung K. Paano natin hahanapin yung K? Using the equation delta G naught equals negative RT ln K. So, hanapin natin yung K. Yun yung tanong sa problem eh. So, lipat mo yung RT. Okay. So, you have delta G naught over negative RT. Then you have an ln K. How do you remove K from the ln function? You use exponential. Okay? O, review tayo. Review ng calculus. Pag yan ay log K, gusto mo kunin yung K, you do the anti-log, no? And this is the anti-log. So you raise the two sides of the equation by 10. So you will have 10 raised to x, 10 raised to log K, and then magka-cancel out yung log, giving you the K. Yun yung anti-log, di ba? Di ba may ganyan sa calculus? Pag meron kang ln function, ano gagawin mo? Pag ln yan, instead of using 10, you will use the Euler's number, the E. Okay? So, make this E raised to x, E raised to ln k. Ano alam natin? Yung E pati ln, magka-cancel out, giving us k. So, di ko alam kung ano tawag dyan. Pero parang antilog siya. But in the Euler's number base. Okay. So, yun yung gagawin natin for this part of the problem. So let us remove the k from the ln function kasi yun yung sinusolve natin. Gawin nating exponent to ng e. So you have e raised to delta g naught negative rt equals e raised to ln k. Or you know e and ln will cancel out, giving you k. So, yan. So we can now solve for k. E raised to delta g naught negative rt. So we know delta g. Alam natin yung value ng delta g. Ano yan? 474.4. 474.4 kilojoule. Okay? So that's in kilojoule. Ayan yung value ng delta G, positive. We have the R. Ang R natin ay, remember, 8.314 joule per mole Kelvin. Okay? So, yun, ano na lang. Okay? And then we have the temperature. Anong temperature to? 25 degrees Celsius. Ibig sabihin, this is 298.15 Kelvin. Magka-cancel yung joule, yung kilojoule hindi. So, kailangan mo siya i-convert, no? 1 kilojoule, 1,000 joule. So, kailangan i-convert. So, you can cancel the joule. Yung Kelvin magka-cancel. Siguro you're asking, no, paano yung mole? Generally kasi, itong delta G, instead of using kj, ginagawa rin siyang kj per mole. So, you can just write the per mole. Okay? You can just cancel it as is na lang. Okay? So, ganun yung common na shortcut na ginagawa namin. Okay? Sometimes it's kilojoule, sometimes it's kilojoule per mole. Okay? So, with that in mind, we can now solve for the k value. 474.4 times 1,000 divided by 8.314. So, I forgot the negative sign, sorry. So, yan, may negative sign sa baba. And the k value is 7.66 times 10 raised to negative 84. Ano meaning niyan? Ano meaning ng value na yan? Kasi alam natin yung delta G kapag positive, non-spontaneous. Ano meaning nun kapag K ang usapan? Okay. Ganito. Balik tayo dito sa table natin. If we have a positive delta G, the K is less than 1. Okay? So, ibig sabihin kapag positive yung delta G mo, less than 1 yung K. Ano meaning nun? Reactants are favored over the products. Ibig sabihin, hindi siya mag-form ng products. Okay? Kaya nga sabi ko sa inyo, ito hindi ito nangyayari normally. Okay? You have to do something para mangyari ito. Di-discuss natin yun sa electrochem. Okay? So, ibig sabihin, we are favoring this more than this. Okay? So, hindi natin i-favor yung formation of the product because K is less than 1. Okay? So, ibig sabihin, yung water lang talaga yung mag-e-exist, not the hydrogen gas and the oxygen gas for the reaction. Okay? So, I will give this to you as a prop set. Okay? So, dito tayo. So, we have number 2, letter A. So, we need to solve for delta G. Given ang K, madali na lang yan. Delta G naught is equal to negative RT ln K. Remember, R is 8.314 joule per mole Kelvin. Temperature. Pag di sinabi 25 degrees Celsius yan. 298.15 Kelvin, ln of the K, KSP in this case. So the delta G value is So the delta G value is in kilojoules. This will be 55.91 kilojoule per mole. Okay. So that's the value of delta G naught. Okay. So yan yung value ng delta G naught. So mapapansin nyo, if you have less than 1 value for K, delta G is positive. Okay. So ganun kasi talaga. Okay. Mathematical yung relationship na yan. So if you have a positive delta G, then your K will always be less than 1. Meaning, yung formation ng product is not favored. Yung reactants yung favored. Ibig sabihin, hindi mabubuo yung products. Okay? However, if you have a negative delta G, meaning spontaneous yan, so the reaction will proceed to the product side. Okay? So if you have a negative delta G, your products are favored kasi going forward yung reaction. Ano yung value ng K mo if that's the case? Greater than 1. Okay? If your delta G is 0, then your K will be equal to 1. Bakit naging ganun? No? Remember, delta G equals negative RT ln K. Remember, if you have ln of 1, ibig sabihin nun, 0 yan. 0 times this is 0. Okay? So, ibig sabihin, if you have a delta G equal to 0, then your K is exactly 1. Okay? So, ano yung implication nun? Ibig sabihin, equally favored. Nasa middle ground ka between the products and the reactants. Okay? So, you are in the middle ground of the formation of products and the reactants. Okay? So, ganun lang. Okay? So, yun na yan. So, yan na yung ating free energy. Siguro, sagutan ko yung isang problem sa inyong, sa inyong assignment. Okay. Para naman alam nyo kung ano gagawin nyo. Pero that's it. Tapos na tayo sa ating discussion. Let me answer one problem na lang. So, siguro itong number 5, tulungan ko kayo dito magsagot sa number 5. So, we have this reaction. Calculate the delta G naught at 25 degrees Celsius and the concentrations. So, that delta G is negative 1 kilojoules. Take that they should be equal. Okay? So, bigyan ko kayong idea paano magsagot ng ganito. Sa letter A, madali lang yan. Bakit? Remember, in solving for delta G naught, you can use the thermodynamic data. Okay? So, we can write for letter A, delta G naught is the sum for the products minus the sum for the reactants. Okay. Alamin mo muna yung mga delta G values mo. Okay. So, tingin tayo sa table. Medyo malayo yung second screen ko. Lang ha. Calcium sulfate. It has a delta G value of, dito ko na lang siya sulat sa taas. So, it has a delta G value of negative 1,3. Oopsie. Negative 1,3, 20.3. For calcium 2 plus aqueous, it has a value of negative 553. For sulfate, let me look sa table. Sulfate. That's negative 741.99. Okay. So those are the delta G values, delta G F values. Okay. So with those values in mind, let's solve for the delta G of the reaction. So easy lang yan. So product tayo. So product, we have 1 mole times yung sa calcium plus yung sa sulfate. We have 1 mole of sulfate again times this delta G naught minus yung sa reactant natin. We have 1 mole times. Okay. So, ayan. Kukulit nila. Anyway, so let's solve for delta G. Negative 553 minus 741.99 1320.3. Okay. So, the delta G naught is what? Let me recalculate. Tignan ko lang kung tama yung solve ko. Oh yeah, so tama talaga. So this is positive 25.31 kilojoule. Positive yung delta G. Ibig sabihin, the dissociation is not really favorable. Okay? Yun yung sabi ng ating delta G. Ano? Okay? So that's the delta G naught value. Okay? But let's answer letter B. Ano daw dapat yung concentration ng products, no? Calcium and the sulfate, so that delta G is negative 1 kilojoule. Okay? Take that they should be equal in concentration. Okay? So yun yung meaning ng square bracket. Pag sinabing square bracket, concentration yun. Okay? So ganun. So since ang given dito ay delta G lang, okay, non-standard yan. So kapag non-standard, we use the non-standard equation. And take note that Q ang kailangan natin this time. Okay? So, yan. How do you write Q for this equation? That's products over reactants. Okay? So, we should write it as this. For the products, we have calcium and sulfate ions. Okay? So, products, calcium and the sulfate ion. Tig-isa lang sila ng coefficient. So, you write it like that. For the reactant, mapapansin nyo yung reactant nyo ay solid. Kapag solid, hindi siya sinusulat. Okay? So, every time you see solid, wag mo isusulat. Kahit liquid, wag isusulat. Ang pwede lang isulat ay aqueous, pati gaseous. Pwede yan isulat sa K or Q. Pero kapag you have a solid or a liquid, hindi mo pwede isulat yan. Okay? So, may malalim na meaning kung bakit ganun. But we will not discuss that any longer. Okay? Though sa ilang YouTube video ko dito, na-discuss ko yon, so please watch them na lang. Okay? So, with that equation, we can now solve for the concentrations. Sabi dito, take note that they should be equal. So, ibig sabihin, kung ito ay X, this should also be X. Okay? So, ibig sabihin, this can be rewritten as X squared. Okay? So, we can rewrite that as X squared. Okay, so, let me rewrite it. Kasi yun yung sabi ng problem, kailangan equal sila. Okay? So, since we are solving for X, transpose natin sila lahat sa kabila. Delta G minus delta G naught RT ln X squared. Divide both sides by RT. You will get delta G ln x square. Okay? O, para matanggal yung ln, gawing exponential yan. So, let me write it here. Ito sa side na to. Delta G naught over RT equals to x square. And since x yung kailangan natin, not the x square, you get the square root. Okay. Get the square root of that value. Okay, so yeah. Let's continue. Solve for x. Delta G is, sabi sa problem, 1 kilojoule. Negative 1 kilojoule. Minus yung delta G naught natin, which is 25.31. Okay. By the way, we should convert it into joule only. So 1 kJ, 1,000 joule. Take note of that. Bakit kailangan i-convert? Kasi yung R natin ay naka-joule lang. And the temperature, it's 25 degrees Celsius. Okay. So with the units now cancelling, yung mole as is na natin siya kinakancel. Kilojoules, magka-cancel, yung joule, yung Kelvin, yung mole as is na cancel na lang yan. So with those values in mind, we can now solve for x now. So you just get the square root of the exponential of negative 1 minus 25.31 times 1,000, 8.314. So x is 4.96 times 10 raised to negative 3. So this must be the concentration of calcium and sulfate ion. Okay? So the concentration of calcium 2 plus and the sulfate must be equal to 4.96 times 10 negative 3 molar. Okay. So siguro yung iba sa inyo no medyo blurry pa yung ano kaya yung mga sinasabi ni sir. Gen chem yun actually no. So gen chem yan yung mga molarity, mga equilibrium constant no. If hindi yan nadaanan, okay lang. Okay? But you can still recall them no. Recall nyo na lang yung molarity no. Okay. The equilibrium constant, okay? But that's how you answer the problem number 5 na. That's how you solve for number 5. In solving for delta G, as is lang yan. Pero yung letter B, pag hinahanap yung concentration, then you have to do all these derivations. Okay? So for number 4, bibigyan ko na lang kayo ng hint. Okay? So you will do the same process for number 4. But siguro you may ask yourself now, pagdating dito sa part B, delta G yan. So, ibig sabihin, you need the reaction quotient. You need the Q. How is the Q written for this problem? Okay. So, in writing Q, take note na Q is equal to products over reactants. So, in the product side, we have hydroxide. Okay. So, we have hydroxide ion square. Aqueous yun, so you have to write it. How about the gases? For gases, instead of using square brackets, we use letter P. Okay? Pressure. Yan. Pressure H2, pressure Cl2. The pressure should be 1 molar. Okay? So, kailangan 1 molar yan. Okay? And yun yung nasa numerator natin. We have the H2, the Cl2, and the 2OH. Yan na yan. H2, Cl2, the 2OH. And then for the reactant side, you only have Cl minus here. Bakit? Kasi yung water, hindi mo siya isusulat doon. Kasi nga, liquid siya. Again, take note, kapag solid o liquid, hindi mo siya isasama dyan. Okay? You don't have to include that there. Only aqueous and gaseous phases. Okay? So take note, kapag gaseous, ganito itsura, letter B. Kapag aqueous, ganito. Okay? However, they imply the same idea lang, no? Na concentrations yung mga yan. Okay? So that's the cue for reaction 4. So you will be able to solve for letter B. Okay? And that's all. No? So, yeah. So thank you for attending our last session for this chapter. I'll see you again next week. Bye.